Hello everyone, my name is Keith Haddock. Thank you for joining. Today we're going to cover a brief summary of the technical report for State Highway 91 and the avalanche path analysis. This is for the Avalanche Science Program and American Avalanche Association Professional Avalanche Training 2. So our objective is to ID avalanche paths on State Highway 91, conduct an avalanche risk assessment, and an avalanche mitigation plan. We have a mountain to drainage scale in the Buckeye Gulch area along 91 at mile marker 2.7 to mile marker 7.1. The temporal scale for this is a 1-year assessment based off a 3-year project plan, and the seasonal forecast will be running October 1st, 2020 to April 1st, 2021. Elements at risk in this case are motorists, pedestrians, Colorado Department of Highways, personnel and equipment, and the state highway itself and infrastructure. So taking a look at where we're at, we're just west of Denver there, just west of Summit County as well, and east of Glenwood Springs. Zooming into the county map, we are kind of on the border of Lake County and Summit County. And a little further, you can see Copper Mountain here on the right and Leadville here on the left. And we fall right here just to the east of Leadville, near Mount Zion, 12106, and Buckeye Peak. A little bit further, you can start to see the terrain features in these avalanche paths right here along the highway. We are right under Mount Zion, and then over here on the right in the unlabeled 12106 peak. So our avalanche risk assessment, we're going to cover terrain overview, snowpack and weather, avalanche path analysis, avalanche mitigation plan. So I've overlaid this here on Google Earth. We have kind of labeled all of our avalanche paths. We have 1, 2, 3 under Mount Zion, and then 4, 5, and 5A under point 12106. I've labeled here some proposed closures for avalanche work. You see our mile marker kind of sets our boundary here within this path. So snowpack and weather summary. You can see here in this rush block we have basal facets and depth ore, roughly the bottom 40 centimeters. Moving on up to our March 13th event, dust event, the upslope, brought about a melt freeze crust with that dust, and we moved into some warmer temps that time and created some more melt freeze crust within. And as of recent, we've been getting slab formation on these melt freeze crust facet combos. And a snow pilot graph I have made here in the Buckeye Gulch area showing basal facets from December and early January up to 70 centimeters, and slab forming over this melt freeze crust at around pencil hard, and again showing those prominent melt freeze crusts of the March 13th and March 20th event. So in this area it's always likely to have some wind, so the stiffened surface snow above tree line and near tree line is pretty consistent. This wind event March 29th brought some big gusts out of the west-southwest, and everything west of there acting as a fetch for Mount Zion here on the right, showing that southeast aspect and getting these wind drifted slabs within those start zones. So our common wind pattern does come from the west, northwest, or southwest, affecting these start zones and cornice growth with cross-loading or direct depositing. And most of our storm flows in this similar direction, so enabling that process. And this avalanche observation from March 30th, right after that event, north of Fremont on an eastern aspect, soft slab, natural, size R1D1, kind of just show good prominent growth on these start zones and what can happen with a little bit of snow and wind loading. So moving on to our forecasting methods for this area. I've laid here, you'll notice this data collection map. We have our telemeter remote weather station there at point 12106, and you'll see these two snow stakes, snow stake 1 above path 1 and snow stake above path 4. They'll be oversized with critical threshold values roughly around 300 to 350 centimeters in the start zone, to kind of aid us in our assessment process. And down low, these question marks are representative snow study plots for our start zones aspect. So up here on point 12.106 and across the way there you see Mount Zion. We're looking back towards Leadville. A remote telemeter weather station up here would provide us the chance to collect temperature, RH, wind speed, direction, and barometric pressure changes in these start zones and associated paths. And we could collect this daily with RC transmission right to Leadville. And this being a table that we can communicate the avalanche hazard rating and the associated procedures for our highway workers in the designated terrain. This allows us to color code a hazard rating, and that gives us standard procedures to follow for best safe work practices. And then again, how many team members we should be traveling in the terrain with. So our avalanche path analysis, in total we have 6 avalanche paths. Path 5A aids Path 5. They connect at a junction lower in the track. The average length of these paths are around 3/4 of a mile upwards to 0.9 miles. So pretty long tracks. Most of these start zones and tracks develop D2 size slab avalanches, although there is a low risk frequency to impacting the highway, roughly one impactful event every 25 to 100 years of a size D3 or greater. And so moving into the Mount Zion zone, you'll notice on the left here, Path 1 has the snow stake above it. This allows us to capture from the road any incremental or critical changes in the start zone. And you notice all these have a pretty southern, southeastern aspect. And if you notice here, most of them have a very pronounced track most of the length of the path, although at the very bottom in the runout zones we are getting thicker forested areas. And this is Path 2 and 3 with a direct line of sight from the road. And if we move over to point 12.106, you'll notice Path 4 is more easterly, southeasterly, and Path 5A and 5 start to turn more east and even generally into the northeast. So Path 5 and Path 5A, you can see they connect at a junction. So if Path 5A was the trigger, it could potentially sympathetic trigger and create larger avalanches out of Path 5. All these start zones do get wind loaded, sun exposure, and slab formation. So some snowpack factors to consider for our risk assessment and risk treatment. Early season, if we're seeing high temperature gradients that facilitate big facet growth. Mid-season, if we're starting to see the persistent slab develop and overlay the persistent weak layers of those buried facets and develop depth hoar. Late season, we start to see lower temperature gradients and settlement and sintering of the bonds. Increased temperatures and shortwave radiation, they start to develop the wet avalanche problems. If we start seeing critical snow depths, roughly 300 to 350 centimeters in the start zone, we like to track our forecast this way. So into our avalanche mitigation plan, here we have a table that displays the path and its appropriate strategies, along with the equipment, practices, and procedures for operational use of avalanche control work. And again, this is one of our daily worksheets for the CEDO personnel operating on the highway. And this allows us to translate daily results onto the next work shift or worker to take the task on. So our Avalancher, we have 4 sites, clear shots for all the paths. It's going to be 1 Avalancher on the back of a pickup truck, and we're going to use AVR 2 Avalancher rounds. And you can see we have direct line of sight from the highways here at our designated areas. So in this path we have Avalanche target location. This is a Google Earth image with the trucks down low that show the blasting sites, and the X marks the target of best potential triggers for these paths if mitigation is needed. So travel advice, if you're traveling to assess the snowpack, avoid any D1 size avalanche potential with consequence and involving terrain traps. Try to stick to 30 degrees or lower terrain, careful and shallow snowpack and boundaries of the wind slabs, and always give these cornices a healthy distance from the edge. So as you dive into the technical report full document of the avalanche path analysis for State Highway 91, you'll find we have snowpack and weather data collection plan, our avalanche path analysis, seasonal snowpack summary, avalanche risk assessment, our mitigation plan, and our forecasting methods. And if you have any questions or comments, please feel free to contact me at any one of these mediums here. Thank you very much.